Hello guys, I'm Vipin Kumar and today we do force and law of motion, which is the ninth chapter of class 9 science. So firstly we do some basics. So first introduction of force. What is force? Now firstly we discuss what is force. So a force is an effort. Force is an effort that changes the state of an object at rest or at motion. It can change an object direction and velocity. Force can also change the shape of the object. So basically what is a force? Force is a effort. Force is an effort that can change the state of an object. Like an object is at rest, we apply some force to it. Like a box is on the rest, we apply force to the box at the direction, and the box will move in this direction. Then that effort is force, because it is the state of the box is rest, and it goes to the the box goes to from the state to the motion, because we apply the force to it in that direction, and the box move in same direction. So the effort or the force is applied to it, help in the change it in the state of the object or the state of the box. Or if box is moving, it has wheel, this box is moving, and we apply this is moving in this side, we apply the force in the opposite side, or we apply the efforts in the opposite side, and the state of the boxes will change. It change from the state of the box is changed from the motion to rest. So the effort which are applied to take the box at rest is called force. So balanced and unbalanced force. There are two types of force, like balanced and unbalanced. When a balanced force are applied to an object, there will be no net effective force acting on an object. Balanced force does not cause a change in motion. So for example, if there is a box, you applying some force to that box, and at the opposite side your friend is standing, he applies same force to the box, then the box will not be displaced or will not be change its state, because from both the side the same force or effort is applied, and because of that the state or the state of the box will not change, and this is called the balanced force. And what is unbalanced force? Like unbalanced force acting on an object change its speed and or direction of the motion. It move in the direction of the force with the highest magnitude. So it means that if this is a box, here your friend is standing, and at the opposite side of the box, you stand at the opposite side of the box, you apply the force of 30 Newton, and your friend apply the force of 20 Newton. So the force which is applied by you is greater than your friend, so the box move in that direction. You apply force in which direction? If you apply force in this direction, so the box move in this direction. So here is an example of tug of war. In this picture, the tug of war is in this tug of war picture of tug of war, the 30 newton of 300 newton of force is applied in this direction and 300 newton of force is applied in this direction. So the force applied is same in both the directions. So the rope, the center of this area, or the whole the rope will not change its state, or will not change its velocity or anything else. Now we come to next. So this is an example of unbalanced force. In this direction, the force of 400 newton is applied, and in this direction, in the right, the force of 300 newton is applied. So the force in the left direction which is applied is greater than the force applied in the right direction. So the rope will displace from here in this direction, in left direction, where the force where the magnitude of force is greater. So net force. What is net force? Like when multiple force act on a body, they can be resolved only one component, known as the net force acting on an object. So what is net force? It means that when multiple force, like in this picture, the multiple force are applied on this rope, or on this object, so they can resolve into one component known as net force. Net force means the addition of all the force which are applied on an object. Like in this direction, the 7 newton is force is applied, in this direction 5 newton, and again 5 newton. So the net force applied is 5 plus 5 plus 7 newton. So the net force which applied is 17 newton on this object or this box, anything else. The 17 newton of force is applied. In next, so now we come to net force. What is net force? So the simple definition of the net force is when multiple forces act on a body, they can be resolved into one component known as the net force acting on the object. For example, as example is given that this is an object and the 7 newton of force is applied in this direction, and 5 newton, 2 times 5 newton the force is applied in this direction. So the net force is the subtraction of the all forces which are applied on an object. Like on this object, the force is applied is in one direction, the 10 newton of force is applied, in other direction the 7 newton of force, all the direction, in other direction the 7 newton of force is applied. So 10 minus 7 is 3. So 3 newton net force which is applied on this object is 3 newton. So now we do the first law of motion, or in the first law of motion, firstly we understand the frictional force. What is frictional force? Frictional force, the force that opposes relative motion is called frictional force, or is called friction. It arises between surfaces in contact. For example, when we try to push a table and it does not move, is because of its balance by the frictional force. So like as you see in this figure, the force is applied on this table or anything else in this direction, and the frictional force which is in the contact of this another surface, this the surface of this box or any other thing is come in the contact of this surface, the surface of this object, and the in these object there is a condition that the surface of the object will not be smooth. So the in these both in the between of the surface of these object, the friction force is appear, and the frictional force applied, and the frictional force applies in the opposite direction of this force. So the frictional force is applied in this direction, but the frictional force is less than the pushing force, so the motion of the object is held in the direction of the pushing force. So now we come to first law of motion. A body continues to be in the state of rest or uniform motion is in a straight line unless acted upon by an external unbalanced force. The first law is also cancelled. The law is also called the law of inertia. So it means that if any body is continuously in a state, like if you are sitting or running, you are continuously in that state or rest of the motion until or unless the external unbalanced force is applied on an object. So here an example is given that this is a football, an object is at rest while remaining. This is football, this is remaining at the rest because and now a player kick this ball, unless act on an object, the force is applied by the kick on this force, the force is began to move. So an object is moved while continuously with constant speed and direction. So this object in which direction the force is applied, this object is continuously moving in that direction unless any unbalanced force is act on this. So this ball after kicking hit the net, and the net apply an unbalanced force to this ball, and the ball will stop. Inertia. What is inertia? Basically all objects have a tendency to resist the change in the state of the motion or rest. So it means that basically all the any object like sand, water, air, or ball, pillow, even human beings have a tendency to resist the change, or have a capability to resist the change in the state of their motion or the rest. So this tendency of resisting the change in the state is called inertia. All body do not have the same inertia. Because it means that the inertia of sand is different from the inertia of water. Inertia of water is different from the inertia of the pillow, or inertia of pillow is different from the inertia of ball. So the inertia of all the object or all the elements are different from one another. Inertia depend on the mass of the body. So inertia is directly proportional to the mass of the body. If the mass of the body if the mass of an object or of an body is less, then the inertia of the body is less. If the mass of the body is more, the inertia will be more. And the mass of an object is measure of its inertia more than mass, or more inertia, more the mass, more the inertia, and vice versa. It means vice versa. The meaning of vice versa means it's opposite, like less the mass, less the inertia. So here is in this figure you can clearly see that the more difficult to be pushed. So the this bucket is empty, so the bucket will lift it easily because the inertia of the bucket is less. If we put and fill it with the sand, the inertia, the mass of the bucket will increase. So the inner mass is directly proportional to the inertia, or inertia directly proportional to the mass. So the inertia of this bucket will increase, and it will more difficult to push or lift up this bucket. Second law of motion. Second law of motion is firstly we understand second law of motion. Firstly we need to learn what is momentum. So what is momentum? Impacts produced by object depend on their mass and velocity. The momentum of an object is defined as the product of mass and velocity. It means that the momentum is the impact which is produced by the velocity and the mass of an object. As like that, this is a wall. No. Okay. Sorry. What? Okay. So this is a wall, and a scooter or any bike or motorcycle is come toward it with the velocity of 50 km per hour, and with the same velocity a truck is come toward this wall, and firstly the bike will hit the wall. There is no effect to the wall because the effect which is produced, the impact which is produced by the bike velocity and the mass of the bike on the wall is negligible. The impact is very less. But with the same velocity, if the truck hit to this wall, the wall will there are many, or there are chances that the wall will break. There are chances that the wall will break and with the same velocity. So why this impact is produced? Because the mass of the truck is more than the bike. So the product of mass and velocity is momentum. So the velocity is same, but the mass will increase. Like the normal bike mass is like assume 120 kg, and an ordinary truck mass is about in the thousands. So like the mass of a truck is 10,000 across, like 10,000. The mass of the truck is 10,000. So the mass of 10,000 will multiply with the 50 kilometer per hour, it will be 5 lakh momentum. The momentum is 5 lakh, but in the bike case the momentum is less because the mass of the bike is very less. So now we discuss about the second law of motion. The rate of change of an momentum. The rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of the force. So it means that the rate at which the momentum will change is directly proportional to the force applied or the unbalanced force applied in the direction of the force. If the unbalanced force is applied in this direction, the momentum is directly proportional to this unbalanced force. So here is a simple formula. The second law of motion, the formula is, what is force? Force is P by T, and this is directly proportional to M bracket V minus U by T. It is directly proportional to this, and we equate them to we get a formula KMA. We get a formula KMA. It means that the force KMA, for 1 unit of force, 1 kilo mass with the acceleration of 1 meter per second square, the value of K is equal to 1. And so if we need of 1 unit of force, if we need of 1 unit of K, so we need a 1 kilo mass. The mass is in kilogram, the K is for the kilogram. So mass is in the kilogram with the acceleration of 1 meter per second square. Then we get a 1 unit of F. Therefore F is equal to ma. So conservation of momentum. Now we come to conservation of momentum. Concept of system. What is the concept in this system? The part of the universe chosen for analyzing is called a system. If any part is chosen for the analysis of anything, then that part is called a system. Everything outside the system is called environment. So anything which is outside from this system, this part of the universe, is called the environment. For example, a car moving with constant velocity can be considered a system. Let me take a car which is moving with a constant velocity. Let we assume that the car will system, and the force within the car, the force which is in the car are internal force. The force which is applied by the car is the internal force, and all forces acting on the car from the environment are called external force, like friction. Friction is a example of the external force which is applied on the car. So now we come to conservation of momentum. The total momentum of an isolated system is conserved. It means the momentum which is created, or the momentum of an isolated system is the conserved momentum. The isolated system is net external force on the system is zero. So isolated system means the net external force, the external force which is the net external force which is applied on the system. In the above, the car is the system, so the net external force which is applied on the car will be zero, so it is a isolated system. For example, collision of two balls A and B. So from Newton's third law, we get we take the mass of the first ball is ma and the mass of second ball is mb. Sorry, here the second law of Newton. And let me take the final velocity of the object or the ball. First ball is va and the final velocity of the second ball vb. Initial velocity of the first ball ua, the final velocity of ball let me take initial velocity of the second ball b, we take ub, and the time is same. So then the formula which come is ma means the mass of the first ball into ua, the initial velocity of the first ball, plus mb into ub, means mb means the mass of the second ball and initial velocity of the second ball is equal to ma into va, means mass of the first ball, velocity, final velocity of the first ball, and mb mass of the second ball, and vb into vb, the velocity or the final velocity of the second ball. Third law of motion. What is third law of motion? Or the Newton's third law of motion states that every action has an equal and opposite reaction. Action and reaction are equal force, opposite and acting on different bodies. It means that, as take an example here, we take an example of the hammer and nail. The force which we applied from the hammer on the nail is if we hit a nail from the hammer, we apply some force on the nail from the hammer, and the Newton's third law says that that nail on which the force is applied from the hammer, it applies a opposite and equal force on the hammer. If we apply the force of 30 Newton on the nail, the equal force 30 Newton of force is applied on the hammer from the nail or by the nail. Inertial and non-inertial frames. Now we come to inertial and non-inertial frames. So what is a non-inertial frame? A non-inertial frame of reference is a frame of reference in which Newton's law of motion does not hold. It means in the non-inertial frame, the three laws of Newton, which is given by these three laws of motion, which is given by the Newton, are not hold. A non-inertial reference frame is a frame of reference that is undergoing acceleration with respect to an initial frame. So it means in a non-inertial reference frame, in a non-inertial reference frame is a frame that is non-inertial reference frame is a frame of reference that is undergoing of the acceleration of the object, undergoing the acceleration of the object with respect to initial frame. An accelerometer at rest is a non-inertial frame with while in general detect a non-zero acceleration. So if there is no acceleration in an object, then it will be non-inertial frame. A frame of reference where Newton's law are held is called or is known as initial frame of reference. So we understand the non-inertial frame with the example of a diagram or a picture. So this ball is headed in this direction. The mg, which is the gravitational force, is pull the ball downside, and the frictional force, the ball is in this direction and the frictional force is applied in the opposite direction, which is in this direction, and this create an angle of 0 degree. Theta. It create an angle of theta. So it means that the ball, this ball is from this observation we observe that the ball which is at here, there are many type of external force are applied on this ball, like the gravitational force, the frictional force, and these force the ball is applied and the ball will make an angle that called theta. So now for more information, for more understanding, we see this video. Wait a minute please.
So now what are we going to do? We'll try and see if we can make up some laws. Let's follow the thread along with people like Galileo and Einstein and Newton and all these people, and let's see if we can create some laws that this world will obey. The world around us will obey. And you already know that this chapter is called Force and Laws of Motion. So there is a plural over there somewhere. So you kind of believe that there are laws, right? You might even know that there is Newton's first law, second law, third law. Yeah, we are here to tell you there's only one law. And if you stick with us, we'll teach you what that one law is. And second, also that Newton's first law is not really Newton's first law. It's kind of one of those little places where they all cheat us, they all lie to us. So let's try and understand what all these are. Let's start off from our old Aristotelian argument. The natural state of things is to be at rest. Is that true? Let's say that is true, for example. Let us just believe that is true. Then let's say you see somebody moving, right? This was the question that everybody had on their mind. Now you might say his state is moving. Therefore, in some situation, someday he has to come and be at rest, right? Someday he has to come back to rest. Great. But what will he be thinking? He will look at you and he will say that, hey, you're moving. Someday you will come to rest. Which of them is right? Are you moving or is he moving? If you stand in a train and the next train starts moving, the train right next to you, almost everybody in the world starts looking out, right? Thinking, okay, am I the one who's moving or is that other train? We all get confused. So the Aristotelian argument kind of had a flaw somewhere because we don't really know who is moving. And the fact that Galileo began to start observing things in the real life in a slightly more deeper manner than had been done before, made him realize something very, very insightful. And that was a huge breakthrough because he said, the natural state of things is not to come at rest because we don't even know what rest is. But if you let some object be, it'll keep going in whatever velocity it has. In other words, he says, if you give a body some velocity, it'll retain that velocity until and unless somebody does something to it. Now, how did he kind of propound this? If you think about it, what he said was, he had a very simple argument. Let me take a little sloped surface, an inclined plane, I drop a ball from it. Right? It's going to go down, and if I keep another inclined plane here, it's going to slide down and go up that. We all know this, right? Now, let me just reduce that incline a little bit, the right one. What's going to happen? He saw that this ball goes down and goes almost the same height where it started from. Yeah, of course, sometimes it doesn't go as much. We call that friction, but it almost went there. Now let's imagine you reduce the spine, kind of the slight even more. Then it goes to the same height even now. So then he asked the question, right? Till here it's observable, it's reality, but this is where the jump from reality to imagination comes. Now he said, if I make the second slope so low that it's flat, then in order to come to the same height, which the ball always wants to do, how far must it go? What is the answer? It has to go forever and ever and ever and ever and ever. It was an argument that he gave to prove what? Or to kind of make people understand what? If you give a body some velocity, we do observe it to be coming at rest all around us. But he said if there is no friction, as they called it. What is friction? When a surface you try to move above, one surface tries to move above another surface, there is some relative motion here and friction tries to stop that because of some bond formation. So if that is not there, if you assume that is very, very, very less, he said the object will keep going on forever and ever and ever and ever. But just because he said this doesn't make it true. Because most people said, hey, I won't believe you, right? I throw this, it stops. He said, but there is friction. But then they asked the question, if there is no friction, how are you so sure it'll keep going on forever? And are we sure? We really aren't, right? We have sent out something called the Voyager into the sky, right? Out into space. And it's kind of not yet stopped today. But does that mean we have proved that it keeps going on forever and ever and ever? It passed Jupiter a few years ago. It passed the solar system a few years ago. It's still not stopped. Does that mean Galileo was right? It means that he was probably right, because if it has not stopped till now, what could make it stop later? But still, people can argue, right? They can say, no, it's not stopped for 150 years, but how do you know it won't stop next year? What if the natural state of things is to come to rest? The truth is, we don't know. In other words, we don't really know, we can't really prove it, but the more and more we see around us, the more and more it makes us believe that if there is no friction, things will keep going on forever and ever and ever. And this can be attributed to Galileo because he was the first person who had the insight to kind of point it out to us. He said, no, things won't stop. They keep going on forever and ever and ever until somebody stops them. And he said in most of our real life situations, somebody does stop them. And who are they? We call them friction. The force that stops objects, we call them friction.
So in this video, from this video we understand that the Galileo says that if an object like a ball is dropped from here and there is no other external force like friction other than the gravity, no other force other than the gravity, so the ball will attain the same height from which it dropped, and it attain the same height and go back to the same height. So if we flat this surface, if we flat this surface, the height will not give to the ball because the surface is flat. The height will at which height the ball want to attain is not there because the surface is flat. So the ball is go from here and it go forever and ever and ever, because and this says the inertia. From this we understand the inertia. From this video we understand the inertia. So this ball is go forever and ever because there is no friction, no force other than the gravitational force. The friction, if there is a frictional force, the ball will stop the ball will stopped somewhere here because the friction is slowly the ball move in this direction. The friction will apply force in this direction, so the ball slowly at a point will stop. So thank you for watching. If you like my video, please subscribe to our channel and click on bell icon for taking my all the updates. Thank you. Have a nice day. Bye bye.